Okay, organic chemistry. Cyclic aliphatic compounds. Hydrocarbons. Hydrocarbons are the compounds containing carbon and hydrogen joined together by a covalent bond. Aliphatic compound. An aliphatic compound is a hydrocarbon containing carbon and hydrogen joined together in a straight chains, branch, or non-aromatic rings. For example, N-pentane, isopentane, neopentane. Open chain or cyclic compounds. These are also called aliphatic compounds. In such compounds, the carbon atoms are joined by a covalent bonds in a straight or dark chain. For example, N-pentane, isopentane, neopentane. Alicyclic compounds are cyclic aliphatic compounds. These are also called cyclic compounds so that those cyclic hydrocarbons which have no alternate single and double bonds and also similar to aliphatic compounds in character are known as alicyclic compounds. Cyclopentene, cyclopropane, nomenclature of cyclic aliphatic compounds, cycloalkanes. Cyclo prefix is added to the name of the corresponding alkanes. Cyclopropane, cyclobutane, cyclopentane, cyclohexane, cycloheptane, cyclopentane, and cyclonone, cyclopropene, 1,3-cyclobutadiene, cyclopentene. Okay, bicyclic or polycyclic compounds, when there are two or more rings in the same molecule joined by two common carbon atoms, such compounds are called bicyclic compounds and name is given by prefixing the bicyclo before the name of the parent alkenes. Rules for naming the bicyclic compounds count the total number of the carbons in the entire molecule, example heptane. Count number of carbon between the bridge heads 2 to 1 in case of bicyclo 2 to 1 or norbornene. Place the bicyclo prefix, use the large brackets. Bridge head carbon, two carbon atoms shared by the three rings are called bridge-head carbons, or in the case of the bicyclic compounds, a bridge-headed carbon is a carbon atom that is the common to two or more rings in a fuse or bridge ring system. These carbons serve as the junction points where the rings are connected. For example, norbornene have two bridge-head carbon. Example, norbornene whose systematic name is bicyclo-2,2,1-heptene. It is the name heptane because it contains total 7 carbon atoms. It is called bicyclo because it contains two rings, that is the breaking two carbon bonds convert it into an open chain compounds 2 to 1 since the number of carbon between the bridge head shared carbon is 2, C2 and C3 and C2, C5 and C6 and 1, C7, bicyclo to 2 octene, 1 methyl cyclo to 2 octene, tricyclo to 1 O heptane, bicyclo to 0 hexene, bicyclo 311 heptane, bicyclo 320 heptane, bicyclo 320 heptane, bicyclo 431 decane, bicyclo 31 nonane. Spirocyclic compounds, compounds containing two rings but only one carbon atom is the common. It's called spirocyclic compounds. Spiro 2 pentane, spiro 452 oct 5 in, spiro 4 to hep 46 diene, Industrial sources of cycloalkanes. Petroleum products is rich in the cycloalkanes and are known as the petroleum industry. Example, cyclohexane, methyl cyclopentane. These cycloalkanes are converted by catalytic reforming into aromatic hydrocarbons and provides major source of these important compounds. For example, methyl cyclohexane produces toluene, benzene produces cyclohexane, and phenol produces the cyclohexanol. Preparation of cycloalkanes by dehalogenation of alpha dihalogen derivatives of alkanes when the dihalogen compounds containing halogen in terminal position on treatment with zinc in the presence of sodium iodide as catalyst gets dehalogenated. The terminal halogen atoms are removed, thereby the closing the ring. The nature of the product depends upon the reactant used. 1,3-dibromopropane reacts with the zinc in presence of sodium iodide, produces cyclopropane. 1,4-dibromobutane reacts with the zinc in presence of sodium iodide, produces cyclobutane. And distillation of the calcium or barium salt of the dicarboxylic acid gives diketones. Reduction of aromatic compounds. Cycloalkanes can be prepared with an aromatic compounds by catalytic hydrogenation at 150 to 200 degrees Celsius. It gives cyclohexane. From dialders reaction, this reaction involves 1,4 addition conjugated dienes with alkenes at temperature 200 degrees Celsius. 1,3-butadiene at 200 degrees Celsius produces cyclohexanes. And from Dickman reaction, it is extension of Claisen condensation reaction in terminal which diesters are treated with base, that is sodium ethanoate or methanoate. Intramolecular condensation reaction occur to give beta keto ester is known as Dickman condensation reaction. Diketo ester in presence of sodium ethanoate, it produces a cyclic beta keto ester. Mechanism first of all, base dissociate gives cation in anion, and anion abstracts the hydrogen and produces the carbanion, which the electron can remove, moves toward this carbon and this electron toward the oxygen, and also come back this electron and this double bond attack this carbon and it moves toward this electron. And this negative charge again come back and remove this weight and produces the cyclic beta keto ester. Hydrogenation, 1-methyl cyclopentane reacts with hydrogen in presence of nickel. 1-methyl cyclopentane. Chemical properties of cycloalkane, reactivity of cyclopropanes, cyclobutanes. Comparing with alkanes, both alkanes and cycloalkanes undergo free radical substitution reaction, but cyclopropane it gives the this reaction shows the unsaturation or instability in the molecule. Cyclobutane undergoes this reaction rapidly. Cyclopropane, and cyclopropane undergoes less rapidly than alkanes. Cyclopropane reacts with the chlorine, hydrogen bromide, and hydrogen. It gives the 1,3-dipropropane, bromopropane, and n-propane. Base strength theory. According to this theory, when a carbon atom is bonded to other four atoms, the tetrahedral angle is 109.5 degree. Any deviation from this value, tetrahedral value, results in strain in the molecule. Such compounds are unstable and undergo ring opening addition reaction by breaking the carbon-carbon bond to relieve the strain. Bare strain theory is based on the following assumptions. Assumptions of bare strain theory. All cycloalkanes are planar or flat, that is lies in the same plane. Hence, the bond angles between the adjacent carbon atoms of the ring no longer remain 109.5 degree or 109 degree 28 minute. Any deviation, positive or negative, from the normal tetrahedral bone angle of 109 degree 28 minutes during the formation of a ring creates a strain in the molecule which makes the molecule unstable. This deviation of the bone angle is known as the bare strain or simple angle strain. The larger the deviation from the normal angle, the greater is the strain, and thus lesser is the stability. Mathematically, angle strain 109 degree 28 minute minus bone angle in the planar form over 2. Relative stability of cycloalkanes, cyclopropane, cyclobutane, cyclopentane, and cyclohexane. The bone angle 60, 90, 108, 120. The angle strain 24 degree 44 minute, 9 degree 44 minute, 0 degree 44 minute, minus 5 degrees 16 minute. Cyclopropane in the cyclopropane bone angle is 60 degree. This implies that the normal tetrahedral angle of 109 degree 28 minutes between any two bones is compressed to 60 degree, and each of the two bones involved pulled by the angle strain. Angle of deviation or angle strain equal to 109 degree 28 minutes minus 60 degree. So the 24 degree 44 minutes. The value of 24 degree 44 minutes, this represents the angle strain through which each bone bends from the normal tetrahedral direction. Figure angle strain of cyclopropane, cyclobutane. In cyclobutane, it has the carbon-carbon bone angle of 90 degree. This implies that the normal tetrahedral angle of 109 degree 28 minutes between any two bone is compressed to 90 degree, and angle state 9 degree 44 minute. This 9 degree 44 minute is the angle strain or angle of deviation through the which each bone bends from the normal tetrahedral direction. Cyclopentane, Bayer assumes that the cyclopentane is a planar molecule, so every carbon-carbon bone angle becomes 108 degree rectangular pentagon, and the angle strain 0 degree 44 minute, which is negligible. Cyclohexane, it is the planar molecule, so carbon-carbon bone angle becomes 100 degree regular hexagon, and angle strain minus 5 degrees 15 minutes. Cyclohexane has outward bone angle distortion, and most stable cycloalkanes in this series is cyclopentane due to the less angle strain, and least stable cycloalkane is the cyclopropane due to greater strain. Decreasing order of the stability. Sachs and Mohr prediction, in order to account for the stability of the cyclohexane and higher members, Sachs and Mohr in 1919 proposed that rings can become free from the strain. Okay, if all rings are carbons are not forced into one plane as assumed by the Bayer. According to Sachs in Mohr prediction, large rings due to their bigger size get twisted in different planes, with the result that the carbon atoms do not lie in the same plane as assumed by Baer. Thus, carbon atoms being in the different planes, their valency bonds are not distorted from their original angle, and no strain is set up in the molecule, so that the rings with 6 or more than 6 carbon atoms get puckered, folded, and becomes stainless. Shear form, wood form. Piezo-strain theory explains the difference of stability of staggered and eclipse conformation around the ring bones of cycloalkane. There is a tendency on the part of the carbon of two carbon linked each other to have their staggered, so that staggered conformation of cycloalkane is most stable due to minimum energy. But the bonds of the two connected carbons of eclipse state and strain is set up in the molecule, and this strain is set up in the molecularized energy. This type of strain is called Piezo strain or torsional strain or eclipse strain. Hence, according to Piezo's theory, the staggered conformation have the least and eclipse conformation have the highest torsional strain or Piezo strain. The energy required to rotate the molecule around the carbon bone is called torsional strain. Factors affecting stability of conformation: angle strain. Any deviation from tetrahedral angle 109.5 results strain in the molecule called angle strain. Greater the value of angle strain, lower will be the stability of conformation and vice versa. Torsional strain: when the carbon atom is bonded, ordered in four atoms including the carbon atom, the most stable conformation is staggered conformation. So a strain caused due to change in the staggered conformation is called torsional strain. Static strain: the static strain caused by the pushing the bulky larger groups close to the each other is called static strain, lose the stability of the conformation. Dipole-dipole interaction: when the non-bonded atoms or groups have opposite partial charge, that results in the dipole-dipole attraction and hence stabilize the conformation. If dipole-dipole interaction leads to stability, will be higher. When non-bonded atoms or groups have the same partial charge, that results in the dipole-dipole repulsion and destabilize the conformation. Conformation: the spatial arrangement of atoms or groups of atoms around a particular chiral carbon is known as the configuration. The fixed spatial arrangement of atoms or groups around the chiral center or double bond that cannot be changed without breaking the covalent bonds, example cistrans, rectus, and sinisters, these are the configuration. But conformation refers to the different spatial arrangement of atoms in a molecule that results from the rotation around the single sigma bonds without breaking any bonds. The spatial arrangement of atoms in a molecule that can change by rotation around the single bonds without breaking the bonds, example Sturgard, Eclipse, Gauss, anti-shear, board, twist board, half shear it is. Conformation of cyclohexene. Cyclohexene has mainly flowing conformation, shear, half shear, twist board, twist board, half shear, and shear. From this graph, the shear form is lower 11 kilocalorie per mole than half shear, and the twist board is the more energy 5.5 kilocalorie more than the shear, and the twist board and the board have the 1.6 energy kilocalorie per mole, then twist board and 7.1 kilocalorie per mole than the shear form. The most stable is shear, twist board, and half shear. Shear form, it is the most stable conformation among all the conformation due to the bond angle is the 109.5 and the carbon atoms are staggered. It is free from the torsional strain and static strain and minimum potential energy. This is the figured shear form conformation of cyclohexane. Both form, in this form, the four pairs of carbon hydrogen bonds occupy the cleaved position, and that is the considerable torsional strain. And a strict strain, it is less stable than the twist board form. Both form lies the 7.1 kilocalorie per mole energy above the shear form. Twist board form, it is in this form the torsional strain and the steric strain is the less than the board form, so that the twist board conformation is more stable than the board form and the less stable than the shear form. This conformation lies above 5.5 kilocalorie per mole the energy above the shear form. Half shear form, it is the transition state from between the shear form and the twist board form. Half shear form has the both angle strain and torsional strain. It lies 11 kilocalorie per mole above the shear form and least stable. Equatorial and axial bonds in the cyclohexane, 6 of the hydrogen which are in the plane and denoted by the He, which are the called equatorial. Okay, E means the equatorial. Which are the hydrogen atoms, the bonds which are hydrogen to ring the called equatorial bonds. Okay, six of the hydrogen which are in the plane are denoted by He, which are called equatorial hydrogen atoms, and the bonds by which the hydrogen held to the ring called equatorial bond. The six hydrogen atoms are perpendicular to the cyclohexane rings denoted by Ha, which is called axial hydrogens, and the bond of the which hydrogen is held to the cyclohexane ring is called axial bond. He equatorial and Ha axial. 1D diaxial interaction, if the hydrogen is replaced by a larger group or atom occurs crowding. Atoms linked by the axial bonds on the same side face cause severe crowding. This interaction is called 1,3 diaxial interaction. Figure 1,3 diaxial interaction in the methyl cyclohexane. An axial CH3 is more crowded than equatorial CH3, and that is the 1,3 diaxial interaction is the axial position. If two axial hydrogen approach the axial methyl more crowded than equatorial, so that cyclohexane with the methyl in equatorial position is more stable than axial 1,3 dimethyl cyclohexane. Diaxial 1,3 dimethyl cyclohexane, diequatorial dimethyl cyclohexane. Conformation structure of cyclobutane. The bond angles of cyclobutane is 90 degree in perfectly square and planar structure, so that there are angular strain as well as torsional strain. The cyclobutane assumes a slightly puckered form with bond angle 88 degree to diminish the torsional strain. Cyclobutane with a bond angle 90. Conformation structure of cyclopentane. The bond angle of cyclopentane is 108 degree, that is the very close to normal tetrahedral angle, 109 degree 28 minute in planar structure. Figure a planar structure of cyclopentane with the bond angle 108 degree. Envelope form and half chair form. The puckered structure of the cyclopentane are envelope form and half chair form. Figure 3-dimensional and the Newman projection of envelope form of cyclopentane. Concept of molecular orbital theory in the stability of cycloalkane. Covalent bond is formed by the overlapping of orbitals having one electron, one is orbital. The greater the extent overlap, the stronger will be the bond formation. In case of cyclopropane, the sp3 hybrid orbitals overlaps along the axis of the molecules with bond angles 109.5 degree, and hence the stronger bond will form, so that it is the more stable. But in case of cyclopropane, the orbitals are also sp3 hybridized and bond angle is 60 degree, and hence the overlapping is minimum, so that weaker bond is formed and unstable. Okay, it's all about cycloalkane under BSc second year organic chemistry, Institute of Science and Technology, Tribhuvan University. Okay, it's all about cyclic aliphatic compounds. Thanks for watching and request you all like, comment, share, and subscribe. Thank you for patience. That is now bye bye. See you.